Hello friends, today we are going to discuss the power electronics, and today we are just focusing on the lecture regarding the inverter. Myself Kinshuk, let's proceed further. In today's lecture we are going to discuss about what is inverter, why it is used, and different type of inverters and their brief introduction. Then we go for the single phase half bridge VSI, that is the voltage source inverter, and the simulation study in online and the reference. Let's go. First questions which is arise in our mind: what is inverter? Inverter nothing but a converter of DC power to AC power by means of static power electronic switches. Now why the static power electronic switches? Because already in a case of the DC motor we have studied that our commutator is nothing but we have one type of converter, but that is a mechanical one. But this is the static switches or static power electronics is used. That's why it is a static power electronic switches. This word is used. Now what is the variations? The AC voltage can be varied, AC magnitude, and the number of phases of the AC can be varied. Now why we need the AC inverter? Reason: already we know that the power electronics is a paper which is only exist as there is no DC transformer and no AC battery is invented. As there is no AC battery, we have to store the charge as a form of your DC. Hence, converting the DC to a AC to give the power of specially say AC motor or drive system or a network from a DC source. That's why the inverter is required. Now type of inverter. Look in this flowchart. It is an inverter, then mainly categorized at VSI, the voltage source inverter, where the source is your voltage source and this one the current source. Now the voltage source inverter further classified as a number of phases, case single phase, or by the technique of switching, say PWM, or the three phase. One by one, for the single phase it may be a half bridge or may be a full bridge. For the three phase, the switching pattern may be the 180-degree conduction type or 120-degree conduction type. Whereas the PWM technique is classified in many ways. As per our syllabus, we are just going to focus on the single pulse width modulations and multiple pulse width modulations and sinusoidal pulse width modulation. This is the most significant one in our real world. Now today we are going to discuss about the single phase half bridge VSI inverter. What is a VSI? That is, as the source, that is a DC source, is your voltage source, and that source should be a rigid voltage source. That's why it is called your VSI. Now it is a half bridge. Why it is a half bridge? Because here we are going to use only the two power transistor, or you can use the MOSFET or IGBT, anything like a switch. Then, and this is the load. Now suppose we give the signal here to the higher, then it will be on, then this is the complete circuit, and this is the reciprocal of this. Always remember the golden rule of that. Suppose it is a leg, never turn on the both switches of the same leg at a time, otherwise the source will feel a dead short circuit. Right? Now let's take a inside of this circuit. This is the two sources. You can create one DC source, then you have to connect the capacitor to make a uniform voltage, and this node voltage is called your virtual neutral point. Now whenever the switch is on, the current flow, that means this plate is goes to it here and this plate is goes to here, that means it is a positive voltage. Again, in the next instant of the time, this switch become off and this switch become on. If this switch is on, then see the negative plates is become this node, then it is a higher potential. So the voltage patterns will be looks like this and that, on and off. Now in the load there is some inductor is there, so the current is little bit sluggish in nature with respect to the voltage, that is shown very uniformly. If we go for the circuit here, click on just a minute. In this environment, you can directly simulate the circuit to get the result. Let's see. Now this is the circuit. Let's come to it here. Let's turn on. For the simulation. Now it shows the simulation study for this. Now first here I am putting some voltage node VG. This is a gate pulse for the gate 1, it is a gate pulse for the 2, it is output voltage across the load, and this is for the current. Let's see the schematic diagram for this. Looks here, I mark this switch as my first switch and it is connected to here the gate pulse 1, and this is marked as a 2, and these two are reciprocal in nature. That's mean whenever this is on, this should be off. Let's see our circuit. Here, turn off this also. Now it is our VG1, the gate pulse 1. Now VG2, if we observe, these two are very much reciprocal to this. Now what is the voltage? That's mean whenever this switch is on, the voltage should be a positive voltage. Let's see. Look here, is a positive voltage same as that of the source voltage. And whenever my negative logic will be the high, then my voltage across the load will be the negative and equal to this voltage. Now look the current pattern. Let's turn off the gates. Now look at here. If we go further, then we can observe here, due to the inductance effect, the current is lag behind the voltage. Look at here, the current is lag behind the voltage. In this way, you can realize the circuit through this online simulator. It is your multisim.com. Here we get the simulation process. Let's come to again to the circuit. Now what is the mathematics? As we know, the output voltage is Vs by 2 when my T is less than my Ts by 2 and minus of my Vs by 2 with it should be a Ts. Should be a Ts. Then that means the negative voltage. Then the average voltage of the output should be a Vs by 2. Now if we recap the concept of your Fourier series, then this is the pattern of instantaneous voltage for this output voltage. Here h is the number of the harmonics. H can be stand from the 0 to your up to the infinity. Here I am putting h is equal to 1 to 3 for all. Note that for all value of the even harmonics, the output voltage should be a 0 because it is a square wave symmetry. Now these simulations can be studied at here. Now for the reference of this small lecture, you can go for this reference book. Thank you for your today's attendance.